What, first of all, is a radical expression? Please say that you have some idea. I think the word radical would give it away. What are radical expressions? Radical, what is the radical sign, Steph? Yeah, it's a square root thing. For example, this, 2 times the square root of 2 is a radical expression. 6 times the square root of 3 is a radical expression. 9a times the square root of 7 is a radical expression. Okay? The key to adding and subtracting them is this. Okay? You are not allowed to, here, let's say I've got 6 times the square root of 2 plus 8 times the square root of 3. Okay? Think about what does that mean? 6 times the square root of 2 means what? Well, that means you have 6 square roots of 2 added together. You have the square root of 2 plus 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 the square root of 2. To that I'm adding 8 square roots of 3. Square root of 3 plus the 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 square root of 3. When I put those together, I end up with nothing. Nothing more than I already started with. I can't put a square root of 2 with a square root of 3. You need to think about radicals as if they were variables. Okay? In other words, you cannot put unlike radicals together. Just like if you had 6x plus 8y, there's nothing you can do with that. The only way that you can add radical expressions together is if they were the same square root sign. For example, if I had 3 times the square root of 2 plus 4 times the square root of 2, that would mean I have 3 square roots of 2 plus 4 square roots of 2. And if I take 3 square roots of 2 and add 4 square roots of 2 to it, I end up with 7 square roots of 2. The square root thing doesn't change. Just like when you add 7x plus 6x, you get 13x, not 13x squared, not anything else. So it's 7 square roots of 2. Okay? So the rule is just like with variables. When you add x's and y's together, you add the numbers in front and you keep whatever it was there. Let's see a couple more examples. Why isn't this switching? Right out of the book. Let me find on here. 9 square roots of 5 plus 8 square roots of 5. 9 square roots of 5 plus 8 square roots of 5. Would give you, Jake Vickery, 17 square roots of 5. To which you say, this seems awful easy, does it not? Somebody say that.
Yeah, seems
Well, unfortunately, children, unfortunately, it's not going to be quite this simple here. Because we might have something that looks like this. Let me find it first. Write this one down, because this is probably going to be the best of the best. The square root of 800 honestly. Square root of 800 plus the square root of 800 plus the square root of 648 plus the square root of 648. Thoughts on that? Kylie, how? They don't cross off, unfortunately. You could say you got 2 square roots of 800, But before you do anything on this, the first thing you need to do is simplify each term. In other words, these things can all be broken down into simpler terms. The square root of 800, the square root of 800 can be broken down a long ways. What can you break the square root of 800 down into? Well, let's look at perfect squares. You could break it down into the square root of 8 times the square root of 100, correct? What is the square root of 100?
10.
So you could cross off this thing and get a normal 10. What about the square root of 8? I can break that down into the square root of 2 times the square root of 4. What is the square root of 4? 2. So the square root of 800 is the same thing as what? Exactly. You multiply your two normal numbers now. This is 20 times the square root of 2. This is 20 times the square root of 2, because they're both the same. Then you'd have to do the same thing to 648. Anybody got thoughts as to what 648 might break down into? Try to look for perfect squares. How about the square root of, you want to go 2? 2 times the square root of 324. 324 breaks down into the square root of 6, Katie says, times what, Katie? 6 times 54. That doesn't really help. Thanks, Katie. The square root of 2 times the square root of 3. The square root of 9 times the square root of 6. Ooh. And the square root of 6 is the square root of 3 times the square root of 2. Square root of 9. Wow. Square root of 3 times the square root of 3. Somewhere along there we could have done it easier, but alright, here's the square root of 2, and there's the square root of 2 that gives us a normal 2. 2 square roots of 3 give us a normal 3. Square root of 3 and a square root of 3 give us another normal 3. And then I'm left with what? A square root of 2 there. And remultiplying this 3 times 3 times 2 is 18. So, if I add all those together, 20 times the square root of 2 plus 20 times the square root of 2 plus 18 times the square root of 2 plus 18 times the square root of 2 gives me, Gwen? 20, 40, 56, 58, I'm sorry, 58 and 8 is, yes, thank you, for 76 times the square root of 2. Does anybody have that? So in other words, the gist is when you come up with this, you've got to simplify it down to its lowest form, and you'll be able to see if you can combine them or not. Or what about this problem here? Maybe I don't see one there. Yeah. I don't know if there's a harder one or not. Maybe one more. Maybe one more. What about this one? 3 times the square root of 2x over 5 plus 2 times the square root of 2x over 5 plus minus the square root of 2x over 5. Your thoughts on that? Can I do something with that? I can. They all have the same bottom number, so I can just add or subtract the tops. I know I'm going to get a 5 on the bottom because that's what happens with fractions. What is 3 times the square root of 2x plus 2 times the square root of 2x?
5.
5 times the square root of 2x minus 1 times the square root of x is 4 times the square root of 2x. And that, ladies and gentlemen, is all you could do. You could also call this 4/5 times the square root of 2x. But that's all she